Hey, so we've finished with primase, and now it's time for our phase of replication. So, it's time to actually replicate DNA. And there's only one enzyme here for this stage, and this enzyme is DNA Polymerase III. DNA Polymerase III is our enzyme responsible for adding nucleotides to the template strand in order to make our new strand of DNA. So, adds nucleotides to template to make our new DNA strand. So DNA polymerase III has an interesting restriction on it that makes it operate completely differently on the leading strand versus the lagging strand. And that restriction comes from two things. One, it can only attach to the 3' side of a primer. So essentially it starts, or if you want to think of it as attach, even though that's not really the right word, it starts or attaches to the 3' side of a primer. That's our first restriction. And then the other thing that makes it operate completely differently on the leading versus the lagging strand is that it can only make 5' to 3' strands. Now, this is not a big deal on the leading strand because the leading strand is 3 to 5. So that means it can, attach onto that 5' to 3', no problem. So here's our DNA polymerase III. And it started over here on the 5' and 3' side. So once this 5' to 3' primer got laid down and we pushed through, right, at the origin, it plopped its first nucleotide down and then started making more. So, not too complicated there. So, on the leading strand, it just attaches to that primer, attaches to the one primer, and then continues laying down DNA until replication is finished. So attaches, so on our leading strand, it attaches, or let's put starts at the first primer, the only primer, and it adds DNA till replication finishes. It's very easy. But you might notice attaching to the 3' side of a primer and then only making 5 to 3 strands does not work on the lagging strand. The lagging strand is 5 to 3. That means our new DNA has to be 3 to 5, right? So we can't attach to the 3' and then start making 3 to 5 because it can only make 5 to 3. And the other problem here is that if we recall, this whole replication complex is acting like a sawmill. So our DNA is being pushed across helices like this. So we can't just move in the 3 to 5 direction. We need some jiggery-pokery. Over here, that's fine. We push our DNA through like a sawmill, and we can just keep clicking new nucleotides onto that leading strand over and over and over again until we've pushed all the way through the strand, or at least this portion of replication on the strand. So, super easy. But here, our DNA is continually being pushed through like this, and it's not going to work, right? So the setup on the lagging strand going to be completely different, and it deserves its own short recording. So this one, well, short and sweet. We will continue with DNA Polymerase III on the lagging strand, where things get weird and there's new vocab. Beep.